Hello everybody, welcome to Dr.K.Liu Math channel. This question is a UK student asked me this question, UK student. I think it is a GCE student and it is the, I think it should be the subject of further math. Okay, let's look at the detail of this question. The points P, 3, 5, negative 21 and Q, negative 1, 3, negative 16 are on the ceiling of a long, strict underground tunnel. A ventilation shift must be dropped from the point P M on the ceiling of the tunnel midway between the PQ or to the horizontal ground level, which where the z coordinate is 0. The ventilation shift must be perpendicular to tunnel. Okay, let me draw the figure to show you what is the x, y, z. That is, I think the tunnel is not perpendicular to the horizontal plane, but it is at that point. Let me show you. That is, I write like that format: 3, 5, negative 21, and Q here. This is Q. This is P. And negative 1, 3, negative 16. Okay, the midway, that is the midway M. I first calculate the midpoint of M. M should be that 1, 4, and that is negative 18.5. Okay, that is midway. And for the ceiling of this one, and there is a ventilation like that. Okay, let's look at detail of this. The path of the ventilation shelf is modeled by the vector equation of this one. This should be R should be x, y, z. That's A. A is the point, should be something, whatever that. And B is 1 st. That is 1. Okay, then solve this one. So s equal to 2.5 t minus 2. Okay, I draw here. Copy and paste. And I think if you have to mention this one, and you have to show that that midway should be, and from this one, that's R means OM plus something in this direction. B should be like that. Therefore, that vector should be right like that, because this is perpendicular. Okay, and it must be that the direction of this one. The direction of this one should be B. B should be perpendicular to this one. You can see that. Okay, then I first calculate the vector of PQ. PQ should be equal to, that is negative 4, negative 2, 5. Then PQ dot B1 st should be equal to 0. That means negative 4, negative 2, 5 dot 1 st equal to 0. That is negative 4 minus 2s plus 5t equal to 0. Then it you can see that as make s as a subject of these things, that you can see that 2.5t minus 2. Then we we have finished the part A. For part B, so that at the point where the ventilation shift reach the ground, which the ground means that there is a ground point. And the lambda should be equal to C over T. C is a constant. Determine the constant C. Okay, and now I write the vector R. R is because the starting point is here. The R should be for any point in this vector. This straight line. We can write OM plus something lambda plus something. That means this vector should be the z coordinates should be 0. Okay, then R OM is equal to OM plus lambda B. OM is let me see, yes, 1418.5. Lambda B is 1, S is 2.5 T minus 2 T. Then at the ground point, that the y coordinate should be equal to 0. That means 18.5 plus lambda T equal to 0. Then lambda is equal to, oh, that is negative. Yes, negative. I make this mistake here. 18.5 over T. Therefore, compare the constant C is equal to 18.5. Yes. Okay, for C part C, using the result A and B, determine the shortest possible length of ventilation shift. Okay, the possible shorter distance should be this distance. Okay, therefore I have to calculate that distance. I call this point G. The distance of GM. GM I write down the vector of mg. Mg should be equal to OG minus OM, and then take the length. Okay, OG is equal to, because when in this case that lambda is equal to 18.5 over T, then I put all the things into this one, OG. That is OG is equal to 18.5 plus this one 18.5 over T, then 2.5 T minus 2 T, and minus OM. OM is this one. Oh, that's so nice. The length, because these are cancelled, we can see that it cancelled. Therefore, the OM, I think I write that square of the length of mg. That is the length or you can call that the length is L square, should be equal to this one. Only this part, because these two parts are cancelled. And 18.5 over T square plus times 1 square plus 2.5 T minus 2 square plus T square. That is the length. That is the length of the length square. And the question requests to find the shortest possible length. That it means the shortest length. I write down that is things, and then multiply, expand the terms inside the bracket. that is 6.25t squared minus 10t and plus 4 plus t squared. Then simplify this one. You can see that that is 7.25t squared minus 10t plus 5 over t squared. And further step, multiply this denominator t squared into this bracket, and you can see that we have sorry, this is 5, not 5t. You have 5 over t squared minus 10 over t plus 7.25, and factorize that 5 outside the bracket. Then you can see 1 over t squared. 1 over t squared, I write that. That is 2 times 1 over t. The final, the last one, the constant term is 1.45. Okay. It is a quadratic equation. The quadratic equation find the shortest minimum value. You can use the computing the square. Okay, I write down this number 5 times 18.5 square. Oh, that the number is not nice. Okay, 1 over t square minus 2 times 1 over t plus 1 square minus 1 square plus 1.45. You can see that 1 over t minus 1 all square plus 0.45. Okay, that shortest distance when t 1 over t equal to 1. And the shortest distance is this times this one, and square root. Okay, and t and L square equal to and that means the shortest distance length should be equal to, let me check, square root. Okay, that is 27.75. That is the shortest length of the ventilation. Okay, that is the part C. Okay, for last part only one marks. Then explain the fact why B actually B is the direction of this, and cause this one and cannot be 0. That is easy job, and you can check that directly because the t should be for any t. You can see that this tunnel is not perpendicular to the ground plane. Because you can see the z coordinates is this is less more deep, and this is relative higher than this position. Q is relative higher than the position of P, and this is in this we have some slope of this tunnel, and once perpendicular to the ventilation perpendicular to the tunnel, then you can see that the direction of this one, the direction is not perpendicular to the ground plane. Okay, I write like that for D part. B is not perpendicular to the ground. I think I use the horizontal plane. horizontal plane. Therefore, B is not parallel. Parallel to the vertical vector, i.e. that B cos 001 cannot be 0. Okay, that is the explanation of this part. Okay, I think guys can enjoy this video. If you found Dr.K.Liu Math channel is useful, please subscribe my channel. Okay, if you actually have any question, you can send message to me, and I hope I can help you. Okay, bye bye.